quick. I like 18 because it really forces you to understand how to scale. All right. Excuse me. Remember that trick that I was telling you guys going through these things? Is to always take a look at where your intercept's going to wind up, which one's going to be your largest, and so on. As you go through your constraints, you guys all okay that we have the largest intercept would be at a 50 for y? And then you've got a couple of 14s, and you've got a 10. We also know it's a quadrant 1 problem, but it also has a cap on the quadrant 1 moving upward at 8. When I have stuff like this, I still do the same trick where I always plot my intercepts, my large intercepts first, and work my way back to it. So, quadrant 1, I'm going to put a 50 up here, label it, excuse me. And then the other one is at 10, so say it's about here.
On the scales of X and Y,
Yes, sir. Yeah, and the reason I put that 10 there because I knew my next ones are at 14. That way I can move it out a little bit further. It's not a big deal. Okay, it does not matter. That first graph, the 5x and y less than or equal to 50, is it shading inward or is it shading outward? Inward. Good. So we know we're arrowing inward. Remember when I told you guys about just drawing arrows like 3 weeks ago? This is the whole reason why we did the arrow stuff 3 weeks ago. Oh, Murphy knew what he was talking about. Every once in a while. And then I do it again with the 14s.
There's someone at the door. No, you can't. Oh, they're just dipping out of the way.
Connect again. Those two ran into each other, didn't they?
Yeah.
Oh, inward or outward, first of all?
Inward.
Those two ran into each other, so we have to figure out where they ran into each other. Now, this is a pretty quick, easy one to figure out. You have x plus y is 14. I wouldn't even have to worry about substituting in this one because your coefficients for the y's are the same. Just to subtract them out real quick. And then I get 4x is 36. And if you did substitution all the time, that's fine. It's no big deal. I just saw that I had the same coefficient, same sign, it being just a single variable, and it's just real quick to subtract it. But if you did x is... What's that?
That makes me think substitution really makes me.
No, that's fine. Go for it. There's nothing wrong with it. Everybody does everything, does this stuff a little bit differently. There's nothing wrong with that. Okay? So now, the y coordinate there is at 9. Oh, sorry, x coordinate. Excuse me. Hi, good morning. So then if I substitute that back into the equation, 9 plus what then is 14. All right, good. Everybody with me okay on that? Okay. The only other one we have to graph now is the y is less than or equal to 8. And the reason why I waited to graph that one after we got this ordered pair is because now, where does that line occur? Is it above or below that dot? It's above the dot. And because the y value for that dot was at 9, or excuse me, the y value is at 5, so the line y is less than 8 has to be above it. So this is at 0, 9, and it's moving down. So that line, that 9 line, that y equals 9, ran into the equation x plus y is 14. Well, for y, yes, ma'am. Oh, sorry. Yeah, thank you. I'm like, wait, I'm looking for where the y was. Thank you. It's still above it. So that's it. And the y value is 8. So the ordered pair there will be something, comma, 8. Yeah, because it ran into the x plus y line. X plus y is 14. Well, if y is 8, what's x? 6. Yeah. And then we have our 0, 0 as our only other point that we have to worry about. So well, if it's asking, the question I think was finding the maximum and minimum values. So in this case, yeah, you would be substituting all 5 of those points. You got 0, 8, 0, 0, 10, 0, 9, 5, 6, 8. Those 5 values you would substitute into your objective function to figure out which one's the largest and which one is the smallest. Okay. I really like that one because if you're not careful with your scale, that horizontal line can be all sorts of messed up when you graph it. Okay? And that happens, and that's a good reason to remember scaling. Okay, it's a good reason to remember scaling. All right. Sure, it's fine. Either one of them is fine. They pretty much are. The 19. I think you had it was mainly a 2-quadrant problem. I think 20 is kind of similar. A manufacturer of ski clothing makes ski pants and ski jackets. Okay? The profit on a pair of pants is $2. The profit on a jacket is $1.50. Both pants and jackets require sewing operators and cutters. There are 60 minutes of sewing operator time and 48 minutes of cutter time available. It takes 8 minutes to sew a pair of pants and 4 minutes to sew a jacket. Cutters take 4 minutes on pants and 8 minutes on the jacket. Find the maximum profit and the amount of pants and jackets to maximize the profit. Hold on. First thing you always want to do here is identify your objective. Yes, sir? Okay, you want to find the maximum profit. What is the maximum profit? So, we know our objective function is going to be about profit. So, in this problem, it talks about profit somewhere.
Oh, so you 2x plus 1.
Yeah, exactly. Now, I like how you said x and y right away. What you're doing is you're saying that the x is going to be pants, and y will be jackets.
Oh, you didn't.
And that's fine. So they're not going to eventually. What we're doing here is we're defining the variable. You're letting yourself know which one's which. By doing that little quick step, it will help you not to mix match your graphs, okay? You keep things straight this way. So we know that pants and, how much profit do you make on a pants again? $2, and on the jacket was $1.50. So $2 for pants and $1.50 for your jacket would be your profit. Okay? Nope. Nope. Doesn't matter.
I mean, I know it doesn't matter, but usually it's like
Doesn't the text order put it this way? C on the other, or is it?
it's C equals.
Oh, I think I usually write it this way because I know that I'm going to get a profit value at the end. So 2 times this plus $1.50 times this will equal a profit. I mean, that's just in my head, but it doesn't matter. Either way, because it's, what is it, property of equality, I think is 3 equals x, x equals 3 means the same thing. Now, in this problem, it talked about 2 what we call constraints. You are restricted on time in 2 spots. You're restricted on time for sewing, and you're restricted on time for cutting. How much time are you restricted by for sewing? 60 minutes. So you have sewing restriction. Why does it have to be less than or equal to?
Because you can't go over the 60, but you can go up to the 60.
Perfect. Very good. Everybody hear that okay?
Yes.
It has to be less than or equal to. Will there be times where it can be greater than or equal to? Yeah, it just depends on how it's worded. Now, you have 2 different articles of clothing here, each requiring a specific amount of time of sewing. How much time did the pants need for sewing? Needs 8 minutes to sew a pair of pants. And how many minutes to sew a jacket? 4. After that, it talks about, what was it? Cutting. When do you have to cut before you sew? Yeah.
Wait. Yeah.
Yeah, whatever.
Oh, they're just cutting off.
Well, maybe it's just not in order, and it does go like that. It's just like we're not in order.
You know, this is why I don't stitch. I can sew a button that falls off. I'm pretty good at that.
You just have to breathe. Doesn't have to be.
How's that go?
You just go.
Do that again. That was kind of funny. You were like on a boat. You're like, I'm breathing out of a boat. Anyway, cutting. How much time do you have to use for cutting?
48.
48. Can we use all 48 minutes?
Yes.
Can I use more than it?
No.
So I can use less than or equal to 48 minutes. How much time do you have to cut the pants?
4 minutes.
4 minutes, and then I lost it, the 8 minutes for the jacket. So it's 4x. Can we have negative pants or jackets?
No.
Do I need to write that down?
No.
I don't, okay? Honestly, when you get into some of these things, guys, it is technically a constraint, but as we're talking about real world stuff here, pants and jackets, I'm not very many people are sewing these things, but anyway, what happens is we know that it's going to be implied that it becomes first quadrant problem. I'm not going to count you wrong if you don't write that down, because you're still going to be graphing it in the first quadrant because it's where it has to occur, okay? So to me, you understand the idea of where things are being applied at. So let's see, we have a graph to make. Jackets and pants, first quadrant. Intercepts. If we go by our intercepts again, if I'm doing a cover and solve for the first equation, we have y-intercept at 15 and an x-intercept then at 7.5.
Yeah.
Well, what's half of 60? What's half of that? 15. So that's how you get 4 and 15. What's half of 15? And then that's how you get to the 8. Anyway, go to the other one. The other scale would have been at 6 and 12 for y and x respectively. So that means I could put a y-intercept at 15. And then that had an x-intercept at 7.5. Connect them. Was this one inward or outward? Inward. It's got to be inward because it's less than. Okay.
But can we just assume that it's going to be inward when there's maximum? I guess.
You can't because it depends on the inequality.
Which one you do?
Right. Yeah, it depends on, are you adding something, are you subtracting something, that kind of stuff too. So treat each one of them separately like we have been. And then again, for the other one, you have x and y intercepts of 12 and 6 respectively. X-intercept of 12, y-intercept of 6. So 12, and then 6. Yeah, and that one's moving inward again. Hey, looky, they ran into each other. I know, right? So now it's just a matter of which method do you want to use. In my head, I look at this second equation. Aren't they all multiples of 4? So it's the same thing as x plus 2y is 12. And it goes to your method of substitution. X is 12 minus 2y. I like using that, especially when I know that the numbers are relatively clean. If I can get a because that's basically a GCF, it's just a scalar. If I pull out that GCF, it just becomes a little bit easier to work numerically. Do you have to do it that way? No. Could you do linear combinations, multiply the top one or by 2 and subtract from the other one? Sure. You can do whatever you want. Yeah. You're still going to get the same values. So if I use substitution here, I get, so I get 8 times 12 minus 2y plus 4y is 60. What's that? It's okay. Don't worry about it. It's not the end of the world. Quick math here gives you 96 minus 16 plus 4. Move the 60, move the 12. We get 36 is 12y. Y is 3. What's your x value? Throw your 3 into here. What's 2 times 3? What's 2 times 3? What's 12 minus 6? 6. So your value here is 6, 3. Right. Well, we don't know. We haven't substituted in yet. Okay. So this gives you your boundary, though. You can make nothing. In this case, if you're maximizing profit, do you have to substitute in 0, 0? No, because you know you're not going to make any money there, right? So if we do this, we have, what is that? We have to test 0, 6, 6, 3, and 7.5, comma 0. Where was our...
2x plus 1.51.
Okay, so let's see, if I 3, that's $9 for the first one. I make $9 on that one. Woohoo! We go to 6. Next one we get 12 and 450, so that'd be, what was it, 1650? Ski clothing might not be the world's greatest profit maker. And then lastly, if I make 7.5 pairs of pants, I know it's not, in theory, it's not your point. It's true. There could be a pirate that wants to go skiing. Right?
Was it completed a half hour?
The average is like 1 to 2 grand for any ski. At like,
It's like making coffee.
I would like, is that more? 1 to 2? I don't know.
Yeah,
It's like the most expensive.
Was it $15? Is that right? Yes, sir.
One thing you could say is that if they completed like a half pair of pants, they're gonna sell it tomorrow.
That's true. Yeah, you can think of it that way. You're halfway through the pants.
Yeah.
So the question was, if you read it, it says how many of each style do you make and how much is your profit? That's where it comes into play, where you want to make sure you label your stuff. You know that this X value stands for pants and the Y value stands for jackets. So I think your final answer would be you need 6 pairs of pants, 3 jackets to make a profit of $16.50. Woo! You are not getting rich in this business. That's true. And I don't know if this is daily or hourly. I don't know. Minutely? Yeah, because you have 60 minutes. Okay. Yeah. Trust me, I got some really crazy, outrageous problems that we'll do later on. They're kind of funny because it's not feasible, but it's just a problem. All right, flip it over.
I made 1,000 of the thing. How does this work?
So now we're manufacturing cars. money that went into this. Okay. So we're going to maximize profits. If we maximize our profits, we knew that, well, defining variables, well, this one's not too bad. It's A and B. We okay with just using batch A and B? If you want to call batch A X, batch B Y, it's fine, but I think it's not bad when it's A and B, because we'll use A's for X's and B's for Y's. Okay? So I can say that this is X and Y. Okay? That way you know which one's which as you go through. Now here's how this table thing works. Did everybody agree that there are two parts in this, two ingredients they gave us, oats and flour? And each batch had a certain amount per each, and it also had a total. So if you look at it, we knew that how many pounds of oats were there and how many pounds of flour?
180 pounds.
So this is kind of how they use the table of this. They just fill in the totals, and then batch A used how much oats? 5 and 3 flour, and then how much did B use? 2 and 3. So what they're doing here is one of them uses, when you're trying to solve for oats, it's kind of like puts it all together, whereas what we said with the Topaz and the Mustangs, we knew that we had 180 pounds of oats. Could you use all of it?
Yes.
Could you use more than it? No. So it was less than or equal to, and then you had two different breads. You had A and B. A used 5 pounds, B used 2 pounds. Basically, your table is one step off of using the actual linear inequalities as you go through. It's just how you set it up, how you read it, how you're looking at it, okay? I don't use the table very often, but it's there. It's just another way for people to help corral what they're thinking. Yes, sir?
Couldn't you solve it by just like figuring out how much like your profit is or how much you're making for each like piece of ingredient rather than graphing?
Just by, but then you have to make sure you know where your feasible region is. Because sometimes there will be a problem where one of the signs gets flipped, and you have to make sure you know which part you're substituting in for. Okay. And then the other one was flour, was what, 3, 3, and 135?
2, 3. It is 3.
Was it?
It is 3.
Oh, was it 3, 3? Yeah. 3 pounds of flour and then.
2 pounds, 3 pounds.
Yeah. So I'm talking flour. Okay. So there, you've got again your two inequality. Are you going to have negative batches of bread?
Oh.
So this is a quadrant 1 problem.
But it's 3 for A and 3 for
One of the things that I would do here, do you guys know how to check and see if something's divisible by 3? What's 1 plus 3? What's 4 plus 5? Is 9 divisible by 3? So that means 135 is divisible by 3.
Wait.
It's been a thing for a long time. What's 2 plus 7? Is 9 divisible by 3?
Yeah.
So, again, this is good. And I think 6s are, it's divisible by 6, it's divisible by 2 and 3. And 9s? Yeah. Yeah. So here, this is the same thing as x plus y is, what is that? 45? It's just another way of doing it. Because then when I do my substitution stuff, it's a little bit quicker. I'm still going to get the x and y intercept at 45 no matter what, because it still works. Okay? We know this is a first quadrant problem, because it has to be. The top equation, my largest intercept would be at 90. And then the x-intercept would be at, what is that, 36? Is that right? 90 and 36? Okay. So I say this is 90. And then this down here would be at, bless you, 36. Inward or outward? inward. The other one's at 45s for each. And lo and behold, they ran into each other. So, set it up however you want. X is 45 minus y. So 5 times 45 minus y plus 2y is 180. 60, 0, 5. 225? So I move the 180 over. I think I get 45, right? Does that look right? I just did that in my head. I just want to make sure I did that right before we run out of time here. Oh, yeah, we're running out of time. So y is 15. What would x have to be? 30. 30. Are we okay with the 30 on that one? Because you know that x plus y has to be 45. And then you take those three ordered, actually you only have to do the three ordered pairs there to figure out which one's going to give it the most maximum. Gee, I wonder which one it is. And then go from there. The questions on this, in this little packet here, I think there's what, 6 of them? The number 2 is pretty straightforward. 3 has 3 of them, so if you can't figure it out, don't worry. 4 is pretty easy. There's a little, one little trick on 4. 5 is pretty straightforward. And 6 has, remember how we had the ones where there's parameters between two values? I think 6 has one like that. If you can get all of your constraints figured out and at least try to start finding them through, go for it. But try your best on these next 6. If you don't get them all, you don't get them all. If you get a couple of them, you get them. If some of them struggle, it's okay. We're doing this for a few days. What's that? Well, we're just starting this, right? I want you to try and get it. If you can't, I don't think you'll be able to get 3 right away, but you should be able to get 2, 4, and 5. Not too much of a hassle. 6 isn't that bad, but what's that? The objective function is what you're trying to do. What's your objective? Your objective is to make profit, and you just look for any $100 off profit. If that's the case, or try as many as you can. If you get stuck on one, skip it and go to the next one. This is just practice right here. I want you guys to practice these before we get going, before we get any more complicated. At least that's the idea.